Hello everyone, this is Tom from Every Step Calculus, everystepphysics.com. You can see the problem here on the screen. X cubed times the square root of 1 minus x squared. The integral of that, of course. And this is a Spanish site that I got this on YouTube here. You can plug this into the search line and you'll come up with it. This is the answer that they get with the substitution of trigonometric substitution. Now you'd think that this would be exactly the same as U-substitution, but it's not. And so I'm going to do this for you now with my programs. Index 8 to get to my menu. Once you purchase my programs for $40, you load them into your calculator here. And you are taught how to put index 8 into here, the entry line here. You press enter and you go to my main menu. I'm already at U-substitution here. Let's make it clear, say U-substitution, because that's what the problem you want to do is generally in a test. So that's what's in the main menu. So you go to there and you're going to enter the function. Now entering the function, you have to press alpha first. You'd press alpha and you'd put in x cubed times square root second square root. I would do that, but the simulator might mess up on it, and I've already entered the problem in the program. X squared times the square root of 1 minus x squared, okay? And I always give you a chance to correct it in case it's not right. I say it's okay. First thing you do is rewrite this to x squared and then put the x next to the dx, okay? In U-substitution, what you do right away is you take the derivative of what's inside the parentheses. Notice that x squared here, that's 2x, right? So we need to be able to match that to something on the outside. So that's the reason you have x dx here. And you should be able to take the derivative of something like this simple in just a second and look at it to see if it might work with U-substitution. If you can't match the outside, then it's integration by parts or some other method. Here's the way you do it. U equals the square root of 1 minus x squared. U squared therefore gets rid of the radical on this side, 1 minus x squared. And then we find out what x squared is equal to using algebra. X squared equals 1 minus u squared. Okay? And then we take the derivative of both sides. D dx x squared equals d du, 1 minus u squared. And that equals 2x dx and minus 2u du. The 2's cancel, so we have x and a minus u here for du. So x dx, remember that's what we separated the first problem with, had x dx on the right here. Well, now we've solved that, so now that's changed to U-substitution. So now we substitute what we found into the actual problem. So we got 1 minus u squared times u times minus u, turns out to be minus u squared. We multiply that through and get u to the 4th plus minus u squared, and both of them by du here for the integrals of that. And we take the integrals of that. We got u to the 5 divided by 5 plus minus 1 u to the 3 divided by 3. Okay? That's the integral of that. Now we factor out u3. Turns out to be minus 1/3 plus u squared divided by 5. We find the common denominator. Notice this problem would never be on a test. That's the reason I initially would never program this problem, because remember, I did these programs for me to pass calculus. So I know that this is not going to be on a test because it's just too complicated, way too many pages, not enough page space on your test paper to write it down, and this is all the steps you have to go through to find the answer. But anyways, I've got many problems that I have. In case you get it on homework, then you can put this in your homework quick and look like a genius. So the common denominator is 15, and turns out to be minus 5 over 15 plus 3 over 15 u squared, okay? And of course we've taken out u cubed here, factored that out. Then we bring 1 over 15 to the outside, along with the u cubed. Turns out to be 3u squared minus 5, okay? We back substitute, put in the square root of 1 minus x squared here to the third power, times 3 times the square root of 1 minus x squared squared minus 5, and the plus c. You always have to add a plus c when you're after you integrate indefinite integral. Now that turns out to be, when you take remember, a square root of something is really 1 minus x squared to the 1/2, and the 1/2 times 3 is 3/2. That's where the 3/2 come into it. And of course the square root is to the 1/2 squared. Well, that turns out to be 1, so then you got 1 minus x squared minus 5. So that's how you get that situation. And we expand it, distribute to 3 minus 3x squared minus 5. We simplify here. 1 over 15 times 1 minus x squared to the 3/2 times minus 3x squared minus 2. Factor out the minus sign. We come up with the answer, minus 1 minus x squared to the 3/2, 3x squared plus 2 over 15. Now notice this problem, you can get the common denominator of 15 here, but I don't know where they get the square root of really, because this is 1 minus x squared 5 over 5/2, so I don't know where they get that from. And this is correct. I'm going to show you why. Let's go here, F3, number 2, to get integration. And we're going to put the function in. X cubed times second square root of 1 minus x squared, and with regards to x you have to put the comma x, because that's what we're differentiating with respect to x. Finish off and press enter. You notice you have your minus 3x squared plus 2 times 1 minus x squared to the 3/2 over 15. So the program is right, this is right. I've never seen this calculator ever make a mistake in integrals or anything like that. Genius program from MIT. Go to my site, buy my programs, and pass calculus or physics. Physics are unbelievable programs too, to do your homework and pass tests, whatever you want to do with them. Of course, you get my fabulous help too. You can send me your tests on my email, and I'll show you how my programs work on your test, and et cetera, et cetera. So I help you as much as possible. Good luck in your classes.